All right. So what's the first thing we always try? Direct substitution. So if we, over here, we get 0 times 1 minus 1 over 0. What does 1 over 0 go to? What does any number divided by 0 go to? Well, in limits, it'll either go to positive or negative infinity. It depends on the left or the right. So let's not worry about the left and right for now. But so this 1 over 0 goes to either positive or negative infinity. This goes to either positive or negative infinity. Okay, and we get this. What is infinity minus infinity? It's not 0. We don't know what it is. It's another indeterminate form. Okay. If these both go to positive infinity, or sorry, let's say the one on the left goes to positive and this goes to negative, this would be infinity plus infinity, which does go to infinity. But we don't know because we didn't do it from the left and the right. Okay. So anytime you get infinity minus infinity indeterminate, we got to do some more work. All right. So this next trick is we just need to combine them into one fraction. So we get a fraction minus another fraction. We just combine them into one fraction. So we just need to get a common denominator of the two fractions. Oops. Okay. So we just need to multiply this guy by something. What do we multiply this guy by? Add 1 plus x over add 1 plus x. Now they have a common denominator. And now if we try direct substitution, we get 1 minus rad 1 plus 0 over 0. Now we get 0 over 0, which is a different indeterminate form. So we got to do some more work. So now what? So we go back to one of our other tricks, multiply by the conjugate, because we got two terms here, especially one involving a square root. So let's multiply by 1 plus 1 plus x. And again, the bottom or the denominator, which we did not choose the numerator, don't multiply that out. Just keep that all factored. And we get set 1. Again, the two middle terms of the conjugate add to be 0. So we get 1 plus 0 minus 1 plus x. Now we distribute this guy. And now what? One of our other tricks. Yeah, can't cancel out the common factor here of x. And now we go to direct substitution and see what happens. So 1 times 1 plus 1. We get negative. Okay, so the very first trick was to combine multiple fractions or the sum or difference of fractions into one fraction. And then also the other trick is keep trying more tricks. Other techniques. All right. First try direct substitution. What is sine of 0? 0. Uh-oh. What do we do here? Okay, this next trick, very important one. You just memorize the answer. Memorize. Okay, this is one of the ones where it's going to memorize that the answer is 1 here. It's not obvious. Okay, so here's our function sine of x and x. As you approach 0, these two functions get closer and closer and closer to each other. And when you divide two numbers that are very, very close, it gets closer and closer to 1. Okay, if I zoom in here, the closer you get to 0, the closer you can't even tell the difference between the two. Okay, and then if I show you this function, y equals sine of x. It's this green function. There is a hole right there at x equals 0. That function doesn't exist at x equals 0. However, you approach from the left and the right, it gets closer and closer to 1. Okay, so the trick is you just memorize this one. Okay. Okay, and one of the ones we memorize is this one. Sine of x over x. What about this? Is this also going to equal 1 or no? It's going to be negative. Just a guess. That's not a bad guess. It's not quite true, but it's not a bad guess. Is this going to equal 1? Why or why not? Is this true what I wrote down here? It is. Yeah. Okay. Right. If you had this, you take the numerator, which is 1, multiplied by the reciprocal, and you get exactly that. Okay. So this limit is the limit as x approaches 0 of 1 divided by sine of x over x. And one of the limit laws that I get handed out is the limit of a quotient is the quotient of limits. So we could write this as the limit as x approaches 0 of 1 divided by the limit as x approaches 0 sine of x over x. And what is this limit? Limit of a constant is just that constant. And this limit we just memorized is 1. It's definitely equal to 1. Okay. So, long story short, limit as x approaches 0 of sine of x over x or x over sine of x is 1. Okay. Very important. So if we try direct substitution, we get 1 minus cosine of 0 over 0. What is cosine of 0? 0 over 0. So, is this also going to equal 1? It's going to be 1? Some people shake their head, no? Yeah, we are also going to memorize this one, but let's figure it out before we get the actual answer. Here's a little trick. We're going to multiply by 1 plus cosine of x, which is just the conjugate of the numerator there. These had to be 0. Does that help anything? If you direct exception, you still get 0 over 0. However, I could substitute this in for something. What is 1 minus cosine squared always equal to? Sine squared, right? Because sine squared plus cosine squared equals 1. So sine squared is 1 minus cosine squared. If you try direct substitution, we still get 0 over 0. Any ideas what we could do from here? What's that? I'm not sure we could do that. Okay. However, sine squared is sine times sine, correct? We have an x down here. So we're going to rewrite this as this. Sine of x over x times sine of x over 1 plus cosine of x. And what is the limit of this guy going to be? 1. So the limit of a product is the product of limits. So I'm going to rewrite like this. This limit is equal to 1. And now we directly substitute in, we get sine of 0, which is 0. 1 plus cosine of 0, which is 1, which is 0 over 1 plus 1, which the whole thing is simply 0. Okay, and what we typically do, or what I typically do, instead of writing the limit of the quotient of limit times the limit, this is technically what's happening. What we typically do is just, we say this thing goes to 1, and the limit x goes to 0 of sine of x over 1 plus cosine of x, and then we get 0 over 1 or 2, 0. So if you ever see me like put arrows here, that's just meaning whatever this function is, it goes to whatever the limit of it goes to that number. Just kind of saves you time from writing the limit times the limit. So, okay, so this is another one we memorize. This is really the only other one we memorize. This is just slightly different. How is this different than the previous one? The last one was 1 minus cosine of x. This is cosine of x minus 1. Is this also going to be equal to 0? Take a guess. Yes or no? Everybody give me a thumb. Okay, let's work it out. It does equal to 1. Oh, sorry, it does equal to 0. If I factor out a negative out of that, I get the limit as x goes to 0. And then one of our limit laws, if we have a coefficient in front, what can I do with that? You could distribute it. Where are my limit laws here? Or was it at the very top? Yeah, here it is. This one right here. If you have a coefficient in front, what can I do with the coefficient? We can bring it outside the limit right here. So this can come out. We get negative 1 times this limit. And then let me rewrite these two. Negative cosine plus x plus 1 is 1 minus cosine of x. And what is this equal to? 0. One of the ones we memorized. What we just did. So it's negative 1 times 0. It is 0. Let's see. You don't really have to memorize it, but again, the reciprocal of this is the same value. And if these are swapped, it's the same value. They're both 0, or they're both 1 and both 0. Let me just write that down anyways. X over sine of x also equals to limit. So the reciprocal is the same value here, and if you swap that, it's going to be the same value. All right, next one. To try direct substitution, we get 0 times secant of 0 times cosecant of 0. What is secant of 0? 1 over cosine of 0, which is 1. And cosecant of x? What is sine of 0? 0. So one of this does not exist. Okay. So we got to do something else. What are we going to do? Any ideas? Figuring out secant, cosecant, cotangent, they're hard, right? Because then it's just the reciprocal sine cosine. So the trick is just change everything in terms of sine and cosine. So all trig value functions can be changed in terms of sine and cosine. So this is the limit as x goes to 0, x times 1 over cosine of x times 1 over sine of x. And now what? What does this guy go to as x goes 0? 1. So if you want to split it up, we can. The limit as x goes to 0 of 1 over cosine times the limit as x goes to 0 of x over sine of x. And then this direct substitution, we get 1. And this we memorized is 1. The answer is 1. So the trick is just change all trig functions in terms of sine and cosine. So here it's not sine of x over x, it's sine of x over 7x. So what can we do with that? Yeah, all we do is we factor this is just a coefficient of like 1/7. We factor it out. We get 1/7 times 1 is 1/7. Okay. But that one shouldn't have been too hard, but let's try this one. Can I factor out a 5 here? Definitely not. You cannot just pull numbers out of trig functions. Uh-oh, so now what?
Multiply by 5 over 5.
Okay, I like that. We multiply this by 5 over 5.
And I factor out the top 5.
And take this guy out. And why did you want that?
Now the denominator is the same as what's inside the trig function.
Yeah, so even though it's not sine of x over x, it's the same exact thing. Okay, and as x goes to 0, 5x also goes to 0. And this goes to 0 at exactly the same rates. If you wanted to, you could let like yeah, let me go. U is 5x. And the limit as x goes to 0 of u. Okay, this also goes to 0. And you end up with something like this. You don't really have to do this, but sine of u over u. And this limit, whatever the variable is equal to 1. Oops, 5. Okay. So the key here is, as long as whatever is inside the sign has to be that same thing down here. This will equal to, well, in this case, 5. So if we're missing a number here, we multiply it by that over that, and then usually bring one over now. Okay. Oh, here's a good one. All right, new topic. We try direct substitution. We get 3 minus 3, or 3 minus 3. We get 0 over 0. What in the world are we going to do here? This absolute value, what kind of function is that? What's that?
Piecewise.
It's a piecewise function. Okay. Let's look at the definition of the absolute value of x minus 3. Minus 3 if x minus 3 is greater than or equal to 0. And if x minus 3 is less than 0. So x minus 3. It's either x minus 3 if x is greater than or equal to 0. Sorry, greater than or equal to 3. And negative x plus 3. Let me just leave it as x minus 3. If x is less than 3. Okay, all absolute value functions are piecewise functions, right? They look like a V. There's two different pieces. Okay. So going back here, we're going to have to write its piecewise definition. So we're approaching 3 here, right? Not from left or right, but both sides. So, but this thing depends on each side of 3. So we're going to have to break these up into the left-hand limit and the right-hand limit. So the limit limit as x approaches 3. Start from the left. Okay, so since we're going from the left, are we always greater than or equal to 3 or less than 3? Less than 3. So I'm going to substitute this for this right here. So this is the limit as x approaches 3 from the left of negative x minus 3 over 3 minus x. Which is the limit as x approaches 3 from the left. I distribute that negative and switch it, we get 3 minus x over 3 minus x, which simplifies to 1. And now let's take the limit as x approaches 3, but from the right-hand side. Now, since we're approaching 3 from the right, this absolute value, okay, we're to the right of 3, so I can substitute this in. So this is x minus 3 over 3 minus x. And how do I simplify this?
Factor out the negative.
You can factor out a negative either from the numerator or denominator. We get negative x plus 3, which if you switch around, they simplify to 1. And now we get negative 1. So the limit from the left exists, it's equal to 1. The limit from the right exists, it's equal to negative 1. So what is the limit as x approaches 3? This does not exist. Just to get an idea of this function right here, I think it looks something like this. Everywhere to the right. It's kind of a cool function. We're to the right of 3, it's always going to be -1, or left to be +1. Okay, so what's this trick? Is we have to break up piecewise functions into its 2 pieces. Okay, and especially involving an absolute value. Okay, so break up. Okay, especially involving anything involving an absolute value is a piecewise function. All right, what are we going to do here? Actually, let's do a, no, let's just do this one. Okay, here we cannot just use direct substitution. If I use direct substitution, you plug in 1 to the function. What is f of 1? Do I plug it into here or do I plug it into here? The top one, because that's in this domain right here. So that's ln of 1, which is equal to 0. Okay. We can't use direct substitution because, well, we can only if we know it's continuous. And we don't know if this function is continuous because this has 2 different pieces. Okay. So especially anytime it changes right here at whatever number this is, we got to just break it up into the left-hand limit and the right-hand limit. So let's start with the left. X approaches 1 from the left. Now, since we're always to the left, what is f of x? Is x squared. So I can write the limit as x approaches 1 from the left of x squared. Now this is a continuous function, so we can't just use direct substitution. If we plug it in, we get 1 squared is 1. And then as we approach from the right of f of x, okay, since we're always to the right of 1, our function is equal to ln of x. So I can substitute in for f of x, ln of x. And again, this is a continuous function, so we can just plug it in. And we get ln of 1, and ln of 1 is 0. So the left-hand limit exists, the right-hand limit exists. So what is this limit as x approaches 1? It does not exist, because the left-hand limit does not equal the right-hand limit. More interesting question is, what if my function here was x plus c? And the question is, what value of c makes this continuous everywhere? So you look at each piece. Is this continuous everywhere? Not really. It is continuous on what domain? Why won't it change colors? As long as x is greater than 0, it's continuous. And it's only this when it's continuous. Or sorry, when it's that function. So this is continuous everywhere here. This is, no matter what c is a polynomial. So it's definitely continuous everywhere here. So the only question is, at 1, we got to make it continuous. So we got to, this is natural log. And then this is just x squared. Oops. So we just have to shift it up or down. So at 1, they're exactly the same value. Long story short, we just need to have the two limits equal. If I put a plus c here, our limit would be 1 plus c. So to make it continuous, we just have to make sure these match. So 1 plus c equals 0. C is -1. Okay, we're going to get to more about continuous functions later, but that was just a little quick question. Let's see.